Okay, so hey guys, it's Quinston, and today we're going to look at this algorithm which has been bugging me for a long time. So I have this phone, okay, and in that phone I have an Android phone. So in it there is a calculator application which is like built into the Android phone interface. And so what happens with that is if you input a string like 3 times 5 plus 2, it directly gives you the answer, and it doesn't ask you for A or B or int A or int B and what are the two values if you want to add, subtract, nothing like that. You just input a string and it calculates the answer for you. Now the interesting part is in this tutorial we're going to learn how that algorithm actually works. So now this is my own algorithm, so I don't know if the Android people actually implemented the same algorithm because this is the one I made, but the thing is that it works either way. So maybe the one which is used in Android is more optimized, but this is how it is actually done. So we're going to use two things in this. We're going to use the binary tree concept. Now why am I using the binary tree concept? Because, well, you have to make an expression tree. Okay, you don't have to make a expression tree, but I just want to show you how you can make an expression tree based on this algorithm. Now what is an expression tree? Suppose you have an equation 3 plus 5 times 2. Now 3 plus 5 times 2 can be converted into 3 plus 5. Okay, now plus is not a very highly precedented operator, but multiplication, yeah, that is a very highly precedented operator. So you have to first calculate the multiplication part, and then you have to calculate the plus part. Based on that, you can make a tree which starts with plus. On the left it has multiplication, on the right it has a number. Similarly, on the left of the multiplication you have a number, and the right of the multiplication you have a number. So if you form that kind of a tree, you can actually easily solve that problem. So that's what we're going to learn, how to make that expression tree and also how to solve a problem. Now in this we're going to use a concept called the infix to postfix. Now this is a stack based problem. So there is like the infix expression. Now the infixed expression is basically just a normally typed string like 3 plus 2 times 5. That is an infix string. So if you want to convert it into a postfix, I'm going to show you how to do that. I have a function which actually does that. I'm going to show you how it works. So without much ado, in the description there is a great link to a video which is absolutely epic, and it shows you how you can graphically how it's done. As you know, I don't do graphics, I only show you the code. So if you want to see how it's done graphically, you can go in the description. Yeah. So let's begin with the code. Now we're going to use two types of nodes in this. One is the classic node, and we're going to use a node int, which is going to be so let's just get to the code. So first we're going to have class node. It takes a character data because I'm going to use characters. You'll see why. A node left, a node right, both are pointers obviously. Node car data, the constructor. This obviously you have to initialize it, and this is one node. Okay, the next node is the node int, which takes a double data. You can have double, int, float, whatever you want. I prefer doubles because they're more accurate. Node int double data, this.data, and these are just getters and setters and whatever. So the next we're gonna just declare some stacks. So at the top we're gonna use a stack which is built into the Java application API. Yeah. So and then we're gonna have a few declarations. Like these are just like null variables which you're gonna use in the later part of the code. Just write them down. You're gonna know what they are soon enough. So then we have the main function. So this is our where the program starts. First we have an expression string. Now here I choose an expression string which is relatively simple. That is 3 plus 2 times 3. Not that hard. The answer is obviously 9, and we're gonna get the answer 9. Don't worry about that. So then we convert it into a character array, and as I say, it's called infix. So this character array is called the infix because it's the infix form. This form is called the infix form. Okay, now we're gonna pass it into a function called the postfixer, which is going to convert this infix string into a postfix string. Now if you want to know how to do it graphically, there's a link in the description, as I said before, to actually convert it into a postfix string. So I'm going to pause the video here, and I'm going to jump to the postfix function, and yeah, that's all. Let's do that. Okay, so this is the postfix function. Okay, public static car, it takes a character infix. So it takes a character array, which I have here. It's the infix array, obviously. So then we create a new stack. Now the stack is going to be a character stack. Why we use a stack? Again, link in the description. See the video. You'll know why we use a stack. Okay. Then we create an array, which is called the result. Now the result is a string, an array, which I'm gonna, return back. See, I'm returning a character array. So that is going to be returned through this function. And that is going to be a postfix string. Initialize the value of the result to, no big deal, I'm just initializing the result array to underscores. Now you can have underscores, blanks, whatever, it doesn't matter. This is just housekeeping stuff. Then we set the count of the counter, okay, for the operation and result. Increment after every use. Why am I doing this? Int count. This is going to be the counter, which is going to substitute as for I. So I'm going to replace result 0 through the infix.length. Now the result is an array which is of the length infix. Obviously, because the infix and the postfix are going to be of the same length. They have to be of the same length because they have the same characters. So I'm going to use the count to count each element in this particular array. Okay. So for int I equal to 0, I less than infix.length, obviously we have to go through every character, I plus plus, system.out.println result. Now this is just housekeeping. I mean, I used this to debug the program, so you can ignore this if you want, you can run it if you want, doesn't really matter that much. And the biggest thing in this entire program is that we're going to use a lot of switch cases. Now I know most of the programs which we make don't use a lot of switch cases, but in this we're going to use a lot of switch cases. You'll see it's pretty big. So in this I'm declaring the first case 0, case 1, case 2, case 3, case 4, case 5, case 6. So if infix I, okay, if that is any of these elements, this code is going to be executed. Now I know that most of you people are used to seeing only one case, and you're going to be thinking, oh my god, there are so many cases, how does this work? If you know the basic flow of a switch case, you probably know how this works. It checks if any of these cases are satisfied, any of them, this code will run. If infix I is 0, this code will run. Infix I is 6, this code will run, but it will break at the end. And this break is very important. Every switch case has a break. If you don't have a break, you probably just don't know how a switch case works. So I think you should go and learn that first. Okay, so result count infix. Now I told you that count is going to be a counter, obviously, for the result array. Okay, so result count is equal to infix I. Now if you don't know why I'm doing this, see the video in the description. In that video, the algorithm is, if you have a number as an element, you directly add it to the string, the postfix string. And if you have anything else, like a bracket or plus, minus, then you have to add it to the stack depending on its precedence. What do you mean the precedence? Division has better precedence or more precedence than subtraction. You divide first, then you subtract. That's precedence. So if you have a number, any number, then you have to add it directly to the result. Result count, here if it's the first number, then count is obviously going to be 0, right? And result of 0 is equal to infix of whatever. And then count plus plus. You increment 0 so you don't get back to that particular value and overwrite it. Pretty simple. Now if suppose infix of I is a bracket. Now we chose a string which did not have a bracket, but suppose you have a string which has a bracket, so we have to deal with those two, right? So let's deal with that. So if you have a symbol, a bracket symbol, then you add it to the stack. You just push it onto the stack. How do you push on the stack? You add it. Now if you don't know how a stack works, I encourage you to go see my previous tutorials or any tutorial online. I'm not very keen on you watching only my tutorials. You can watch whatever you want as long as you learn it. So stack.add infix I. So you just push this bracket on the stack. Infix I is going to be bracket because that's the case we're going to check. if the case is bracket. Now if you have seen that video in the description, you would know that when the bracket arrives, we have to pop the elements from the stack. Okay, we have to pop them. So while the stack is not empty and stack.peak is equal to brackets, you empty the stack. Basically you pop the stack. Now why am I doing this? Because the bracket is useless. You're not going to add or subtract with the brackets. So wherever you have brackets, you should remove them. I was keen on not adding brackets at all. I mean, just skipping over the brackets. But I thought that, come on, I have to cover everything, so I just pushed them on the stack anyway. If you don't want to add brackets to the stack, you do not need to do it. But I thought that I should cover everything, so I added them to the stack. And I'm popping them over here because they are useless. You're not going to do any mathematical addition, subtraction, anything with brackets. You just need them for, precedence purposes, I guess. Now, if stack is, after popping the brackets, stack.peak is a function which you use to peek into the stack. It returns the topmost element in the stack, so just keep in mind. And you know what and conditions do. So if stack.empty, and invert that, if stack is not empty, result of count equal to stack.pop and count plus plus. You pop the stack and you attach it to the result count. If you have seen the video in the description, you know what I'm doing. If there's a bracket, you pop the stack and then you just add it to the result, okay, and count plus plus, because you don't want to get back to it. Now I can even do this. Count plus plus can be written over here, so I'll dynamically increment it in the same expression, but it's not necessary, so it's more simple like this. And done. Break. That's all. Bracket, you just pop and add the result. That's it. When you have a bracket, a closing bracket. Then we come to the bigger things. That is plus, case division, or case multiplication, case subtraction, and case division. The same thing. Pop the stack if there are any opening brackets. If the stack is not empty, checker equal to stack.peak. Now this is basically a variable which we declared at the top of the program. Yeah, at the beginning of the slides I showed you some housekeeping stuff. That is this checker. It's a car type. So if 0, the precedence is same. If 1, the first precedence is more than the second precedence. If 2, the first precedence is less than the second precedence. You might think that I'm crazy because I didn't explain this. I will. Check precedence is a function which will return 0, 1, or 2 based on their precedences. If it's same, if 1 is more than the second, and if 1 is less than the second. Okay, so let's move on to check precedence. When you evaluate an expression like 1 plus 2 multiplied by 3, you always have to check the precedence. If multiplication has bigger precedence, addition has lesser precedence than multiplication. So I'm going to pause the video here and we're going to jump to the check precedence function. Okay, so we are here at the check precedence function. Public static void check precedence car A, car B. It takes two cars. Either is going to be a division or a addition or subtraction and addition or whatever, any combination of the above operators which I mentioned in the previous slide. Switch A. You can switch with B. I thought it was easier to switch with A. Case bracket. If A is a bracket, if A is a division symbol, switch B. Okay. Now, if A is a division symbol, B could be a division symbol, B could be a asterisk, B could be an addition symbol, or B could be a minus symbol. So you check if division, they are the same precedence. So return the decider. I didn't return here because I thought this would be a global variable, so it can easily be used. Returning just adds a bit of complexity to the program, so I didn't want to do that. Decider is going to be, I'll show you what the decider does, but let's just think about it as a return type. So division, return 0. Division asterisk, return 1. Division addition, return 1. Because division is more than asterisk, as I told you. If first is greater than the second, return 1. If first is greater than the second, return 1. If first is greater than the second, return 1. Break. Now case asterisk. Now all of these cases are the same. I'll tell you why. Because if multiplication is greater than division, well, no, it's not. So return 2 because the first is less than the second. I think you got the idea, so I don't need to go through every one of them each. It's pretty simple. All the switch cases. So return, so decider. Okay. Now I'm going to pause and go back to where we left off. That's all in the entire, Okay, so we are back to check precedence. So you realize what I'm doing. I'm setting the decider based on what the precedence of the input infix I and the checker is. So if decider is equal to 1, if decider is equal to 1, stack.add, okay, because if you have seen the video link in the description, you'll see that if we have an element which we're adding to the stack, okay, and that precedence is more than the one of the element which is already in the stack does not pop. It adds to the stack, okay. But if it's 0 or 2, you pop the stack and you add it to the result, okay, and then you add the element which you have which the checker has basically, okay, not the checker, the infix of I, sorry, okay. Else, now we have here if the stack is not empty. Now this whole code is if the stack is not empty, but if the stack is already empty and you don't have any elements in the stack, you just add the element to the stack. It's not a big deal, just add it to the stack. Okay, default done. Or this is probably never going to be reached because all of these are characters, and I just wanted to type out defaults because there's default. Okay, so this is an extra sentence. Now why do you do this? Sometimes what happens is when you go through the entire stack and you just pop everything, you have some elements which are useful remaining inside the stack, and you don't want that. You want the stack to be empty as much as possible. And if you don't empty the stack at the end of the operations, you are going to lose some amount of data and you're going to lose accuracy of your program. So while stack is not empty, you need to empty everything. You need to empty everything and add it to the result because it's going to be useful. Without this, your program is useless. It won't work. It might work for a few cases, but not for all of them. If you have brackets, this is not needed. But if you don't have brackets, if your program doesn't have brackets, you need this piece of code. And it will run or not depending on whatever, because this is a while loop and it has a condition. If it only runs if the stack is not empty. And return the result. Now where do you return the result? Over here, of course, in the main function. That's where you return the result, right? Then system.out, the postfix form is, oh sorry, the strings do not match, do they? Doesn't matter. I mean, this is just an example. So system.out, the infix form is, and we're going to print out the infix form. That is not, like, we're going to check if while it's not equal to underscores, because we don't want to print the underscores because that's just unprofessional. Then we create the postfix form, create the tree out of the postfix form. Now what happened here is we got our postfix form, okay, character postfix. We went through the postfixer and returned the postfix form. Now what we need is we need to create the tree out of the postfix forms. Now I know that most of you people who are studying computer science, you know what a expression tree is. You just create like binary trees out of expressions. Like you take the plus and then you make links to other nodes with numbers and other operators basically, and you get the stack and you get the tree. Okay, now for int I equal to 0, I is less than postfix.length I plus plus. Now why postfix.length? Because you want to go through all of the characters or elements or whatever you want to call them. So first we're going to make a node. Now you know what the node declaration is, and we're going to initialize it with a character. If you don't understand this, go to the first slide. Switch postfix I. I'm going to check and have conditions. I told you we're going to use a lot of switch cases. We're going to switch from postfix I. Cases 0 through 9. If any of these are hit, this is happening. No, if it's a number, it's going to be directly pushed onto the stack. is going to be directly pushed onto the stack. And if it's a addition, subtraction, division, or multiplication, you're going to have node.right stack.pop, node.left stack.pop. Now, you know, I'm saying this in a very casual manner. Node stack.pop is always going to be a number. I know it's always going to be a number. Why? Because I'm pushing everything on the stack, right? Do you believe me? Think about it. Is it always going to be a number? It can be a number, it cannot be a number. Because stack.push node. See? I just pushed the addition, subtraction, division, and multiplication back into the stack. So this is not always a number. This can be addition, subtraction, division, and multiplication. Now, if you don't understand this, what I'm going to say is you take a piece of paper, you take a normal expression, you know, the one which we use or any other expression you want, and just go through it and push it one by one into the stack. And then you follow the switch case and see what you get. I swear you're going to get the exact, the exact expression of that tree. Okay? I think this is pretty straightforward. I don't need to explain this a lot. This is just a basic creation, and it's not as difficult as the binary tree. I know the binary tree was big. It's not that hard. Pretty easy. And then root will be obviously equal to the last element which is in the stack. Root equal to stack.pop. Pop. Okay. System.out root ln print ln root.left.data. You can write, if you want to check the if the elements are exactly in order, you can do root.left.data, root.left.left.data, root.left.left.right.data in any combination, or you can use a basic in order traversal, post order traversal, any traversal you actually have learned about. Then after the expression tree, now let's actually solve for the values, because you have made the expression, and if you didn't solve for the values, it's useless. And this part, solving for the values, has nothing to do with the expression tree, which is, when I was making the tutorial, making the code, I was like, hey, it has something to do with the expression tree. But as I started making it, I'm like, there is no, even if you don't make the expression tree, you don't actually need this to solve for the values. It's preposterous. I know, it's so disappointing. Okay, so for this you just need a stack. Okay, and I just made the stack. It's not that big of a deal. So for int I is less than postfix. Now, okay, this stack is basically a node int form. Okay, it's not a node form, it's a node int, because I'm going to deal with integers. I said doubles, I know, but whatever. Integers make no, it is double. I think this is a mistake. It is a double. I'm sorry. We're going to deal with doubles, but yeah. Okay. The int is a typo. Yeah, I overthought myself. Anyway, it doesn't matter. It's going to work the same. You can see the code. Okay, for int I equal to 0, I less than postfix.length, because we want to go through all the elements. Node int equal to new node int 0. Now I'm going to just initialize it to 0. And postfix I cases 0 through 9, as always. Node int equal to new node int character.get numeric value postfix I. Now, what does this whole function do? This function actually converts a character into a value, a double value, an int value, or any value which is imaginable. Int stack.push node int. Now I'm going to push the numbers on the stack. System.out println node int.data. I'm just checking if the values are true and correct. Then case plus. Now what if there's a plus? System.println pushed double x. See, it's a double. I'm sorry, it's not int, it's double. It's just a misconception. It's kind of confusing though, even for me. Double x is equal to int stack.pop.data. Now I popped the stack because there are some numbers on it. Okay, here only the numbers are going to be in the stack. There is not going to be addition, subtraction, any of those symbols in the stack. Okay, because it's a double type. The stack is a double type. So they're going to be only numbers inside the stack. double x equal to int stack.pop.data, double y is equal to int stack.pop.data. The top two values are going to be instantiated to this, and then we're going to check node int.data equal to y.x. Node int is basically the instantiation of that node int class, and yeah, and this is the answer, and then we're going to push it back onto the stack. So in this whole program, the stack is a very important part of it. Now all of the other cases are just this copy pasted a lot of times, and this character replaced by multiplication, division, subtraction. That's it. And then at the end, you actually get the value. See, everything is the same. Now we're going to use the top values. Now this stack is going to contain only numbers, okay? Because see, I'm not pushing any of these, I'm just pushing the data on the stack, not the addition, subtraction symbols. So it's just like that. And yeah, well, I think that's the end of the tutorial actually. Yeah, that's about it. So I'm going to show you the code. I'm going to pause for a while. So this is the code. I know it's pretty huge, but oh well, let's run it and see what happens. How do I detach? I hope you can see this. So this is the pushed string 3 times 2. I inputted over here. The string which I inputted was 3 plus 2 times 3. So the infix form is 3, 2, 3 multiply plus, and the answer is 9. So these are just the the debugging options. So yeah, that's about it. Thanks for watching. If you enjoyed this tutorial, don't forget to subscribe, like, and yeah, it's pretty fun. I like making tutorials, so if you want me to make more of them, just support. Thanks for watching. Later guys.